Alright, hello and welcome to Lab 4. This one is all about the list abstract data type. Before we get started, I want to mention that you can work in pairs now, okay? You have progressed to a point where I'm alright with that. So you can assume that any other lab after this, unless I say otherwise up here somewhere, you can find a partner and work in a pair, okay? No more than a pair though. And both of you must submit separately to the autograder, so it's still, you'll get each other's code that you both worked on somehow, and just upload to the autograder and you're good to go. And you should also include a comment in your code saying who you worked with, so I don't try and falsely get you in trouble, okay? That is the idea, because you did not plagiarize, you worked in a pair. So that's the idea there. Let me know if you want some tips on how to transfer code between yourselves. I can even show you this fancy thing called Git if you're interested. And yeah, post on Piazza if you want to search for a partner. I think that's probably the best place because everybody is supposed to be on there. And yeah, hopefully somebody just makes the first thread and you guys can all jump onto that one so that it's not a million different questions looking for partners and it's just one. Hopefully that works out. But yeah, that is logistical stuff. Let's get into the lab. It's going to be due in 2 weeks because midterm. Alright, so the first thing that you can do with this lab, after you get the code and everything, is practice debugging with GDB. And oh, I'm sorry, that didn't, I need to make that prettier. So I gave you this file. There are some simple errors, I know, but I want you to get some practice with running this program in GDB, stepping through it, getting to the error, seeing what line the error was on, seeing the values that caused the error. So I very much encourage you to work on this. It is optional, but it will really help you when you implement linked lists. Okay, so you're going to implement this linked list class from linkedList.h. This one right here, it's going to be a linked list, so a list abstract data type implemented as a linked list, holding nodes which have 0.2ds as data, which are like x and y values. So it doesn't have to be an int, it can be anything. And you don't really have to worry too much about that. You're just going to be shuffling whatever the user gives you along. And then of course your next pointer. So those are your nodes, and it is your job to implement all of these public member functions. Okay, so you'll do that in linkedList.cpp. And I've given you some hints in the lecture about this, but one thing that I do want to do, and I didn't have enough time to do in lecture itself, was let me go through the entirety of essentially the push front operation. Okay, I'm going to implement that for you, and we will have it together. So here is insertion from the slides. So I'm going to follow all these steps, but I'm actually going to do it in code for you. All right, so we'll do it together. And I'm going to just make up my own stuff. We're going to work on nodes from class, so struct node int data node star next. And I am going to make node star first and node star last. And I'm not going to give you this code, by the way, so just a heads up. I'm going to make a function called add int to new node at end of list. So it's essentially pushback, and we can give it first and last, let's say. A reference to them, I guess we're going to need that. And you'll understand why these are references in a second, as well as pointers. It'll be void, and we're going to want to add an integer, so new val to put at the end. Alright, so the idea is I'm going to implement pushback essentially in a non-class function. Alright, so I'm going to take in the first and the last and use that to build up a list. I'm going to start my list out empty, so that means the first and the last are both null. And then, for example, if I wanted to add the number 1 to the end of the list, I'd call my very long function looks like Java with first, last, and 42. Okay, and I can do this with 43, 44. Okay, so I'm going to make a list with 42, 43, and 44, hopefully by calling this function 3 times, because it's like the pushback function. Okay. And I'm taking first and last as references because I want to change them. You won't need to do this at all in your actual implementation. Because, as you know, once I add the first node, I'm going to have to change first and last to not be null anymore. And every time I add something to the end, I have to change last. Okay, so here are my cases. If first and last are both empty, the list is empty when we push, the first and last pointers must change to point to the new element that we made. So the very first thing that we always need to do is make a node that we're going to put our new val into. Okay, so I'm going to say node star new node equals new node on the heap always. On the heap. It's important. So now I have my node, I can set its data. It's new val, and its next is always what? What do you think? It's always going at the end of the list, and the end of the list always has, the last node in the list has a null next pointer. Okay, so that's that. And alright, now it's our job to plop that node in the list, represented by first and last. Alright, so let's follow our steps. So let's check this empty case first. So if the list is empty at the beginning, then we better change them both to point to the one element that's in the list. So it's going to change from a size 0 list to a size 1 list. So if first is equal to null pointer and last is equal to null pointer, so that's the condition that makes it empty, then we're going to say first equals last equals new node. Okay? So the first is the last because it's a size 1 list. Alright, otherwise, we'll do the normal case of, I guess we're doing push back instead of push front. We're going to bring that node to the end of the list and change the next pointer on the old end. Okay? That's the idea. So here we go. I need to make this node the new end. So it needs to eventually be like this. We have to say last equals new node. But before we do that, we have to make the old node. We need to change its next pointer. And the reason for that is, well, it was the old last node, so we're putting our node at the end. That's like 42, 43, or 42, and we want to add 43 right to the end there. We want it to turn into this. Well, we're going to take the old last element and put us as its next pointer, of course. Okay, so last, before we've changed it, its next pointer is not going to be null anymore, it's going to be us. Okay, oops, so there's that. Last arrow next equals new node, and then we can finally set our node as the new end. Okay, so now it's pointing correctly. Anything else? We made the node, we brought it to the end of the list, we changed the next pointer for the previous last element, so we're putting a new one right down here at the end. Then we set the last pointer and we handled the empty case. So I think we're probably good to go here. But we'll find out if we have any bugs when we print out this thing at the very end. So for node star n equals first, n is not equal to null pointer, n equals n arrow next, cout, n data, new line. Alright, let's see if this worked. It compiled, and we get 42, 43, and 44. So this is essentially what you'll be doing for your pushback function. Okay, and hopefully you see why it works now, and why all these cases are very necessary, especially that empty list case. Oh man, did we need that to actually start off the list, because otherwise, if we only ever changed the last pointer, we would never have a first to start the list with. Oh no, we couldn't have iterated. Okay, so that's that, and that's essentially your lab. So after you're done with that, you can play Snake, which is really fun. So I encourage you to type make snake once your list works, and then you can use the arrow keys or WASD to move the snake around and eat its food. I think you'll enjoy that, but of course you won't turn that in. I've made it for you. Feel free to yell at me during office hours, and I will tell you exactly how it's implemented, because my code is kind of ugly. And then you'll submit your only one file this time, linklist.cvp. Okay? And I've made the entire tests for you. So you can say make linked list tests, and it will run the tests that I've made. Those are enough. All right, so you'll be graded for those tests passing and then also not leaking memory. That's about it. So good luck. You have 2 weeks to do it because of the midterm, and you can have a partner if you want. So I think that's plenty of time, and you are set. So I'll see you next time.